I'm going to talk about a project that I worked on for a class called Brain Body Music this past semester on data sonification. Um, and Glenda is here. She is a composer who worked on it as well. And she can tell you about her trials and tribulations getting the recordings for some of the sounds that we're using later on. Um, and yeah, that's what we're doing. So I'm going to talk a little bit about what data sonification is. Basically, it means turning data into sound. Um, and so on one side here, we have some sea surface temperatures, which is the data and I ended up working with for this version of this sonification project. And then we want to take that image and turn it into a sound wave. Some classic examples of sonification, Geiger counters, right? They go click, 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 right? Hopefully they don't do that because that means there is radiation. Um, and crosswalks. Yes, yes. Hopefully not, but that's how it is, sadly. Um, and um, and then also crosswalks, the kind of beeps that tell you which way the crosswalk is going. But you can also use sonification for much more complex data. There's tons of this out there. I encourage everybody, if you're interested in this, to check out the Data Sonification Archive. I think there's, so there, just this first page has some New York City evictions sonified, and um, and some spectroscopy also sonified in there. And there's a bunch of other things. I think there was a famous one the New York Times did um, of COVID. So it was like sort of the sound of New York City um, during COVID and how everybody was staying home. And the reason that as scientists we might want to do this is that the human brain is highly skilled at recognizing patterns through sound, especially patterns over time. So we don't always have really great ways of showing data, complex data over time, in a way that our brains are good at picking up on. And you can see here in this image, which this is some functional MRI images of a newborn's brain. And you can also see that like sound that's like music is having a much greater impact on the brain, even a newborn who's had no musical training of any kind versus kind of this altered music, so sound that doesn't have the structure of music but is similar in other ways. And it's also great for accessibility, inclusivity, and outreach. People love music, so it's a great way to get people involved in science. And it's also potentially, the data is a rich source of inspiration for artistic expression. So this really has the potential for some great cross-disciplinary collaboration. So I'm just gonna play this composition. I have the video up, and then I'll tell you how I did it. But I want everybody to have a chance to listen to it and see what you hear and what you notice before I do that. And these images on here, these are global sea surface temperatures, and they correspond to the sound. So. And we originally, I don't know if we have room in here. Originally, this had kind of like a VR component, and we were all like laying on the floor, listening to it and watching clouds go by. So if anybody wants to like do anything remotely like that, uh, that's cool. Otherwise, we can like sit and do whatever you do when you're listening to music. Um, so I guess I noticed some things, but I'm curious what other people heard, or saw, or combination of in there. Mhm. Mhm. Yeah, so I can show you. Bob, did you want to say something?
So first of all, it was beautiful, and it reminded me of the biosenses, but also the sonified data. And I'm thinking of like a very loud calming along the road, or anything that has an alarm call, where as cars drive by, the alarm calls start off on this end and they just travel like a wave as the conversion comes down. So they're tracking on the movement of what they perceive as a potential threat and they're making alarm calls. Part of that, I don't do that. So anyway, that's what I was thinking as this was going. It's like something is going by and something is by.
Yeah, Kaylee.
I was thinking of like I'm sitting outside and having and what's in place. Because the background was kind of, I was like, this is what is the background noise? I'm not thinking about like what it but if I was saying if I was going for more music and other pieces of if I was flying away from it, I didn't have that voice.
Yeah. Yeah, for sure.
I was fishing somewhere.
Yeah.
That's why in Wisconsin, it's all around. So I'm like fishing myself sitting.
Yeah, for sure. Well, why don't I tell you how I did it and or how I made the sonification, and then we could, well, we'll see if people have other thoughts, and we could also listen to part of it again and see if we hear something different. Oh no. All right. So the trick with this particular sonification is that we're starting with images, which are not that easy to represent in music. So I wanted to get like a time series of data. So there's a bunch of ways that we can do this with kind of unsupervised learning to get different like key components. The one that I used is called a variational convolutional autoencoder. So I could have gone like a principal component analysis route. That's like a pretty typical thing to do with sea surface temperatures, and I'm interested to try that as well. But originally we had been looking at images of clouds, and so I wanted something that was not going to be dependent on like the rotation of the image necessarily, or like the placement of stuff within the image. And I wanted something that was going to be pulling out the components that are really responsible for the most variation, because that's what we want to hear in the sonification. And so that's how I arrived at the variational convolutional autoencoder. These are the components here. You can't really tell anything about them from where we're sitting. And each of these components have weights, and they can then, the weights can then be used to reassemble these images. Usually they're a little bit fuzzier when they're reassembled, but they look pretty similar. Or we can take those weights, and this is a time series plot of all the different weights in different colors of blue. And we can make them the volume for different musical tracks. And so that's what we did. So if you hear a dominant track during part of the composition, that means that the corresponding feature is prominent in the image. And these are all the different audio tracks. I might put Glenda on the spot since she collected all of the audio tracks, in terms of like what did you do or how did you choose?
And so they're all, 10 different layers. So originally all the sounds combined together about, when I was going after the students, I was isolating these, and I was going thoughts, I was just comparing the thoughts, so the individual layers, and you're probably well aware when you run around the idea of how the COVID is to actors that your sound being out of traffic, or an airplane, or somebody, you know, with so much noise, the wind boulder. And so it was actually, I encourage the practice of just, if you try to record a sound in nature, it's a lot more difficult to get a sound without running a lot of other noise in the recording. So I think that is the longest to do it with. So we're walking through Bobo, all of them is if I write is inside of them. So walking through Bobo, like to me for some joy. But that's so water, birds,
Yeah. Yeah, so I can play a little some of these. So, oh, the leaves, yeah. Yeah. And then oh, dripping water. Yeah. Okay. Let's see. Yeah.
Yeah, people like to do that, so I have to then I have to run them through a system to try to do out a lot of the activity. It's really impossible to put it in.
Mhm. There's the infamous gates. In the springtime. Mhm. Mhm. Oh, let me see. I'm not sure if I can get over to where I have the titles. And then this is the blackbird. Oh no, the wind. I think it was with the frogs. Cool.
And that took so many hours. It doesn't seem like it would, right? You hear those things, but to get an audio recording and to try to get as clean as possible recording. Is in the collection of the sounds and then the EQ of each track to try to get rid of all the extra debris. I would recommend for field recordings with the Zoom recorder. It has this one, the mics, and you can also get like these. That's those Zoom recorders.
Oh, it's six.
Mhm.
Yeah. Yeah, I mean, the film is in
Yeah.
if you want, yeah.
I was thinking six.
Cool. Question in the back?
Why would I find audios online? The out in the and then, so the experience of the happening and the sounds, that's where all magic is.
And so being able to share something with the rest of the group that has come from the earth. And, what was something? How did you decide which specifics of your looking? We talked about that a little bit, and part of it was the sounds that were available. Also,
Yeah. I didn't do any like assigning sounds to particular components. So I guess I've listened to this a couple of times. So what I hear is when the polar ice comes out is when the geese come in. And when it goes away, then we hear what I think Kaylee you thought was a fire, which we don't know what it is. I'll look it up as soon as we're done. But so the fire the kind of fire-like sound I thought was very appropriate for the temperature. I don't know about the geese. We could maybe get in like the wind or something and assign that to that vector. But those were like the patterns I was able to pull out. I did notice some years where like we suddenly heard sounds that I hadn't heard in any other year.
Also, if I could ask, during for the virtual reality presentation, we had a seasonal meeting. So trying to also think about.
Yeah. Yeah, for sure. Yeah, I think that that could be interesting with these sea surface temperatures, especially because we do see so much seasonal variation. Yes, Bob.
I was looking at this, I didn't get married, I was watching the interview and trying to see when there's unusual patterns, can't hear something. The thing will come out to me. Now, one of the few hours of actually used natural harmonics when everything goes in, you know, external sounds. What would that sound, what would that in picture look like?
Yeah, I think we talked about doing that as well. You mean kind of like doing a Fourier transform on the image and then that was sort of the first thing that I tried. And it was a little while ago now. I think I decided not to go that route mostly because not because of the sounds, because I didn't have the sounds at that point, but I just wasn't seeing enough variation, at least with the cloud images. But yeah, that's one of the reasons why I mentioned I would be interested in trying the principal component analysis, because I think with that we would certainly come up with El Nino and La Nina, as well as like probably the ice coming in and out. But yeah, so the choice of algorithm was really down to what I could get kind of vectors that looked pretty like independent and different to me. Yeah, we do have something going on in kind of the second half. It kind of shifts. And so I wonder if that's an artifact of the way that I did this, or if that's something that's really in the images. So I think there's a lot of other playing with the data that I like to try to do. My worry with the FFT is just that I think you have to be very careful about it because one of the things that we learned in this class is that like the the natural harmonics of like a 2D image are going to be different from like those of a sound wave, and our brains are like doing a lot of filling in the gaps for us. So like there's kind of like a harmonic series with sounds that would probably be different in the two-dimensional image, and like even if the like your brain will actually hear like the sound at the bottom of the harmonic series, even if that sound isn't present, but only the harmonic series is there, which is kind of interesting. But I just wonder, yeah, I think it would take some work to get something that our brains recognized as like music and not noise by transferring the FFT directly. But I don't know for sure. Yeah,
This is much simpler that requires better music activity, not that we're using.
I've been up there, but I haven't been to the museum.
I have the same where they show average temperature of the globe,
Mhm.
and it starts to a really low pitch, and you can like hear the seasonal variations, and then it gets higher. And higher. I thought that was really impactful. Yeah, which we need to
Yeah.
temperature. I'm wondering if like something like that would be incorporated into your methods of material.
Mhm. Yeah, and maybe by like kind of selecting the sounds more intentionally, we could I thought we sort of had a little bit of that going on by accident with the kind of like the sort of crackling noise happening in the hottest part of the year, but yeah, I think that probably we could do more, even more with that. It's a great idea. Yeah.
There's no sound from steel, kind of steel.
Mm-hmm.
I think this would be amazing. The background Indian sound, the season, what of your sound so sweet. For those who don't know this one, you know it, but it's a very large physical sphere with you job to say your job to
Yeah.
work for radio. And some awesome, I'm thinking, they're great when you see this stuff. It's just because of that. I mean, especially when people also realize, wait a minute, it's in sync with what we're looking at.
Yeah. Yeah, I think that would be cool. It was well, when we did this performance in the class, I mentioned there was a VR component, and it was very cool. I mean, it was mostly it was mostly like kind of sort of like auto-generated clouds based on the weights also, but like I think, yeah, Science on a Sphere or an IMAX or the VR, I think really adds to the ambiance.
I'd love to get into the weeds, just timbre nuances or pitch to your point, like to focus on certain components. This is a nice broad overview of the day out in the field with the sound sonically, but it would be fun to come in on that thing and just those nuances. Like if you just did water and had 10 effects on water, it just slight variations and like use that for whatever stuff like that.
Yeah. Yeah, I think that would be super cool. Yeah, you're seeing a little bit of it. This is kind of like we had the project and the deadline. And so we were trying to get something out there, but now that we have something, I think there's a lot of room to do that. I was thinking maybe I would play just a little bit of the beginning again, now that everybody knows what's going on a little bit more, and see if people hear something different. Because that's also, we were also interested in that, like whether we should tell people before or after they hear it, how we made it. So I'll play a couple years worth. There's, by the way, there's 23 years in this. So another possibility with some data sets would be going back to like the 1980s, maybe with a Landsat or something like that. This is with the MODIS satellite. So it starts around 2002. Um, anyway, so yeah, how is that different for people if it is at all, or, yeah. Yeah, I can.
It's like, because you don't have to go back to the beginning, it's like everything, there's a lot more east sounding, you know, when you get to the end. Like,
Mhm.
further in.
Yeah,
I think it might be cool to push the year.
yeah.
See how it changes across the years.
Mhm. Yeah, I did think like for me, I think that was like the most the sea ice and the geese was like sort of the most clear like signal I was hearing.
Well, Joe's not here too, I think we should do that.
Yeah, we gotta call over. Anybody know someone at NOAA? It's NOAA, right? That has the, yeah. Well, at that particular part of NOAA, I guess it would be important. It's a big place. I think Anna maybe knows some people. Yeah. Okay. Mhm.
So I've seen them live on TV.
Uh-huh. Yeah, very cool. Cool. Alright. Well, that, ah, okay. So, yeah, many thanks to Glenda, of course, and the other students on our project were Leo Ma and Tyler Grimes. I think they're both students at Atlas on main campus for those who are familiar with CU. And then Dr. Grace Leslie is was the professor in the class, who's I think a joint appointment with Atlas and the music department, or maybe just Atlas, and she teaches in the music department. So, yeah, we don't necessarily need to use the whole time. I thought this was just a cool thing to share. And thank you all for coming down. Yeah.
What about rail time, like conversion of it? We're taking a new productivity and turn it into like that behavior, move.
Mhm. Yeah. I I think the answer is yes. I would have to think about how to do it, but I think it could take, if we wanted them to be images like a particular set of images, then we can like learn, like do this auto encoding to like transform the images into a set of weights, and then you can also rebuild images from the weights once you have the auto encoding. So yes, but yeah, it'd be pretty fun. I don't know if anybody saw the Maurice Sendak exhibit last year. I mean, we've got a lot of people in from out of town, but he had a bunch of like cartoons that he wrote basically while listening to Mozart. So that was his version of that. But they're pretty cute. Yeah. Well, I'm just gonna I'll just turn this back on, and folks can kind of take like thank you for coming, and we'll see you later in further.